Can we write cot x is equal to cos by sine? So if we say this is I, our integral can be written as 1 over 1 plus cot can be written as cos x divided by sin x and dx as it is. Taking LCM in the denominator, it would look like integration of 1 over sin x plus cos x divided by sin x and dx. Okay, now this is the denominator, the fraction, the denominator will be multiplied as a reciprocal of this function. So integration of 1 times sin x, this will look like sin x divided by sin x plus cos x. Now, whenever you have any function in this form, what we would like to do is we would like to take denominator as t, and it would be wonderful if its derivative can be shown in the numerator. That's what our objective is. The derivative of sin x plus cos x would be cos x minus sin x. So we want cos x minus sin x in the numerator. Now, how would we achieve that? So what we are going to do is, let's see here. Excuse me a little bit. Let's see. Let's make this partition and can we multiply and divide both sides? Be little attentive here. So what we are going is we are multiplying and dividing both numerator and denominator by 2. Now numerator becomes 2 sin x and denominator, this 2 I have written outside this integral sign, and the denominator sin x plus cos x is as it is. My purpose is to write derivative of this of the denominator in the numerator, and we know the derivative of sin x plus cos x is cos x minus sin x. So what we are going to do is we are actually adding and subtracting. We are going to add cos x and we are going to subtract cos x. It's like you are adding and subtracting something, it will not make any difference in the function. Now, this can be written as, okay, dx was there, let it be. So 1 over 2 as it is, integration of. Now we want to write it as sin x plus cos x as it is, 1 sin x plus cos x as it is. And as we said, we want to write derivative of this function, which is cos x minus sin x. So if I write this way, minus cos x minus sin x. Now, this numerator is still same as the numerator here, but it's written in different form. Of course, after this bracket, we have dx, so we need some space there. Let's write it little neatly. So what we are saying is we are writing here cos of x minus sine of x and the dx there, and this divided by sine x plus cos x. Now look, this is reduced into a very, very simple form where we can apply the standard formula of integration. This now looks like 1 by 2 times, we'll split it in 2 parts, 1 by 2 times integration of sin x plus cos x divided by sin x plus cos x dx minus integration. This half should be there because now we are separating these 2 parts. So half time cos x minus sin x divided by sine x plus cos x and dx. I think this is clear. We're just splitting this integral in two parts, or this fraction inside, this function inside, we have split in two parts. So what the first part is, you see the denominator and numerator being same, will get cancelled. So we get half time integral of 1 dx 1 times, and minus 1 by 2 times the second part. Let's say this is I2 or I1, this integrand I1. Now my I is equal to, my integral would be half time 1 dx minus half I1. Please note this equation, half time 1 dx minus half I1. Now we are going to solve this I1. Let's write this I1 cos x minus sin x by sin x plus cos x. Okay, so my I1 is, let's write here, is equal to cos x minus sin x dx divided by sin x plus cos x. Now in this part, put denominator of this fraction, which is sin x plus cos x, is equal to t. Derivative of this would be, derivative of sine is cos. This will imply derivative of sine is cos, and derivative cos is minus sine x times dx will be equal to dt. Means our integral is now looking like, I mean our I1 is now looking like integration of dt over t, which is, if we apply the standard formula here now, which is log of mod t plus c. Let's say c1, c, just like c1 is also a constant. Finally, we want to write our I, and we remember our, okay, should we retain the value of t before actually writing this integral I? So I1 will be equal to log of, in place of t, we are going to retain the value of t. Here it is, sin x plus cos x plus c1, and then I can be written as half of integration 1 dx, and half of I1, it will half of 1 dx plus or minus, I think this was minus sign over here. Yes, minus half of this value here, half of, let's write it, log sin x plus cos x plus c1, bracket close. I would like to write it little clearly. So minus half of log sin x plus cos x plus c1 and bracket close. See, when you will integrate this one, this would be equal to half of 1 means x plus some coefficient here, some constant here. Let's say that is c2, a number. No? We always add a constant here. And minus this part is half of log of sine x plus cos x plus c1 by 2, because this c1 will also get divided by 2. when you open the bracket. And you can write your answer finally. The answer would look like this. So your I is equal to half x. We can say x by 2. Yeah, that's a better way to write it. X by 2 minus 1 by 2 log sine x plus cos x plus c, where c is equal to, you can write here, where c is equal to c1 by 2 plus c2. Actually, these are some constants, c2 and c1 by 2. So when we add constant, we'll get another constant. So this is your answer.